Hello and welcome to DevSecTalks. I'm your host, Ashley Ward, and today I'm joined by Nathaniel Q Quist, threat researcher at Unit 42 and Prisma Cloud. Unit 42 is the global threat intelligence team for Palo Alto Networks that collects in-depth information about security threats. In today's episode, we'll sit down with Q to learn more about his role with Unit 42 and take a closer look at some of his recent cryptojacking and cloud threat research. Let's dive in. I'm really excited about this episode now because I'm joined by possibly the coolest person I know, certainly, and probably in tech. He has a letter for a name. Q, why don't you introduce yourself?
Awesome, thank you, Ashley. My name's Nathaniel Quist. I do go by the letter Q. That could be Star Trek, that could be Bond, depends on however you want to do it. I personally like Star Trek. I think snapping your fingers and like changing the universe is like amazing, but making cool things and being a quartermaster would be pretty amazing. I'm a threat researcher. I work with Unit 42 and specifically Prisma Cloud. So there's just a couple of us, like two of us researchers that are focused on the threats that are facing cloud from a external perspective. And I get to work with a lot of really smart, talented people in Unit 42. So, my main focus is I look at how can the cloud be attacked and who would be attacking that. So I look at what are the threats that are available, what does that landscape look like, and then where are the holes that we can poke at to see if somebody is actually using that. They have malware that's associated with those kind of attacks already happening, and can I track them? What are they doing? And then I report on it. So it's fun stuff. It's a good gig.
Tell us something about some of the research you've done recently.
Yeah, most certainly. On a bi-yearly basis, so twice a year, my team and we create something called a cloud threat report. So it usually comes out the first half of the year, so around the April timeframe, and then second half of the year around late September, early October timeframe. And we've done things like we've done red team exercises on environments where we actually will have a client approach us and say, hey, can you look at our cloud environment? Are we secure or not? So we'll sample different things. Some things that we've really looked at are like identity and access management misconfigurations. So we'll see if we can see that if an organization has like a misconfigured in it, we'll see if we can get into that environment and then own the environment, and how fast can we do that. So when we did it last time, we owned the entire cloud environment in about 3 days, which is pretty impressive. And then recently we're doing another ones. And again, we find the different kind of attack points, and then we exploit them to see if we can gain access to it. So I do research from that, and then I also look at blockchain and cryptocurrencies and who's manipulating that and who's doing cryptojacking on that aspect. So it's kind of a wide field. Every day is kind of a new adventure.
Yeah, absolutely. You get to poke at things and see what breaks. It sounds really cool. I actually got to see you speaking once recently, in fact, and it was about the whole cryptojacking thing. Now, you'll know a lot better than me. I'm pretty sure you'd said that actually cryptojacking was dropping off.
Yeah, it is. So from our last report, so one of our cloud threat reports we did in October of this last year, it was we saw about 17% of organizations that have cloud environments experiencing some sort of cryptojacking operation. That was the first decline that we have seen. Prior to that, it was 23% of organizations that are experiencing some sort of cryptojacking operation, and that was on a constant uphill truck, if you would, from 8% when we started tracking it back in 2017. So it was going up and up and up, and now we've seen the first dip in cryptojacking operations. So it's pretty cool. I like that.
Yeah, no, absolutely. And so, I mean, obviously, as an entrepreneurial type person myself, I've got my 1/8 of an eighth of a Bitcoin. What kind of currency? I mean, is it tokens? What kind of things are people mining?
Yeah, so I mean, as we probably all know, that there's there's hundreds of cryptocurrencies that are out there, and each kind of cryptocurrency, each kind of crypto blockchain has its own features, its own specialties, its own things that it does really well. And aside from Bitcoin, and Bitcoin is like the gold standard, if you would, but there's other coins that do other things. one coin in particular. It's called Monero. I lovingly call it the criminal coin, just because it's the only thing that the actors would really want to use for cryptojacking. For a number of reasons. One of those is it's really easy to mine. You can mine it off of your phone if you wanted to. You can mine it off of your Apple TV or anything that has a processor can process it, right? I don't know of any attacks for Apple TVs yet, but
that's maybe the next report. I'll help you with the next one. That's great.
That's the next thing. So it's really easy to mine. That is really cool. In cloud environments, most cloud instances, resources, like EC2 instances or virtual machines or RQL systems or whatever kind of system that you're making in the cloud, they primarily run on CPUs, right? So they're not using graphic processing units or large video cards or something like that. They're just using simple CPUs, and that makes Monero really attractive because it can run on a simple CPU. It doesn't have to use a big GPU like Ethereum would or some of those other coins. Other things that make Monero really popular and really cool for actors is it has a lot of security features in it. Security being good because we like security, but criminal actors would like security as well because they don't want to be tracked. They want to have decent encryption. They want to have obscurity in the noise. So Monero offers all of those things. So it makes it really attractive for actors to want to have it. Oh, and it also has a very large marketplace. So there's places like Darknet, which is like on the dark web. There's marketplaces. One of those marketplaces is called Darknet. Other places are called like Ultimate Net or something like that. And you can literally buy anything. So if you wanted to buy guns or drugs or anything that you could think of, it's on there, and they only take Monero for the most part. So it's a good place to sell it.
Isn't the whole point of the blockchain and then things built on that it'd be quite traceable? I would have thought that even though it's widely accepted and easy to mine, it's like, yeah, but look, I got all the transaction history. It was you.
Sure, yeah. I mean, and that is true for coins like Bitcoin. Everything is on a public ledger, and every address that makes any transaction, either buying or selling, is put onto that ledger. So you know exactly that this wallet did this attack, or did this transaction at this time for this amount. I mean, everybody knows that. It's accountability, right? Monero's is different. It doesn't have that necessarily. You have your address, and your address is on the public ledger, and you can see that transactions have occurred. But when a transaction is actually happening, in the same way that we have encryption for, we're sending emails or something like that, we'll use our PGP key and we'll privately sign this, and our public key can open that up and we can see what it is. Inside of that blockchain, Monero blockchain, we have that same public and private key inside of that. So I will make a transaction and I will use my public key or my private key to sign that specific thing. But I'm not actually going to use my address. I'm going to use something called a one-time address. And that address is only used at one time, and it's associated with that transaction in my private key. And then it gets sent out. And then whoever has my public key can open it up and see that transaction is actually valid. But anybody else, if you don't have my public key, or if you certainly don't have my private key, you'll never be ever able to see that transaction. And if you do that sort of action, nobody else, unless you have a private key, can see what transactions are coming in. You can only see what transactions are going out with the public key. So there's a lot of anonymity that can go into that. You don't know the address for one, and then you don't actually know how to open it or see it because you don't have the rights to do that.
I'd imagine you annoy some people being a threat researcher and being on the good guy side.
Yep.
Who are some of the people? Who are some of the groups? Talk to me about that.
So it's actually fun. So there's this group. They're a German group, and they're called Team TNT, like Team Explosive. And they actually they're one of their main actors. His name's Hildegard, at least as far as we know. That's the handle they use. And they've actually sent Twitter exchanges saying, Unit 42, you're going too fast. You got to stop doing this, And so they're taunting us, being like, "Oh, you guys got almost the first version. You got to sharpen your pencils and start working more," And it's kind of funny. So it's like, but they're very loud and verbose, which is really kind of interesting. It's like, it's like they almost want to be caught. They just want to tell people like, yeah, we're doing this and we don't even care. Look, so.
From a DevOps point of view and bringing security in, and I mean, what you do anything with that, or is all your research just really on the ones and zeros?
Yeah, no. So we're looking at like how do we strategically place cloud in a more secure location, like cloud operations and all those pieces. So a big part of cloud and a big part of DevOps is using something called infrastructure as code. As cloud is all ones and zeros, there's no really hard there's no hard infrastructure anywhere, at least that you use and interact with on a daily basis. So where do you get how do you stand up new systems, and how do you make it dynamically scalable and take advantage of all this new stuff that cloud allows us to do? And the best way to do that is with infrastructure as a code, a template. It's basically like scripted infrastructure. If you want to write a script for something, and you can just run it off and then it'll go do whatever it is you want it to do, you can script that and you can say, I want, when XYZ happens, I want, 14 new, web applications turned on or whatever. And it'll go and it'll dynamically build all of that using whatever script you created. With those scripts, and you can you can get these scripts anywhere. You can get these. There's a lot of repositories. Say Docker Hub is an example of where you can pull down a very specific image that you would want to stand up in a cloud environment. But if you go to other places like Artifact Hub is a repository similar to Docker Hub, only it gives what is known as a Kubernetes Helm chart. And what Kubernetes is basically a cluster of images, right? And what a Helm chart does is it automatically, it'll create a lot of the automated functionality behind it. So it'll build all of the network infrastructure. It'll build all of the communication pathways that'll go from those clusters out. And it does that on a push button sort of basis. So it'll build this whole cluster out. Now with those clusters, and when you start dynamically building all these large things all together, you want to make sure that each one of those individual instances is actually secure. So it's something that we call shift left, in that if you can secure that very one individual instance, then when you're building 1,000 of those at once, you know that every single one of those 1,000 instances that's being built off that one piece of code is secure. But if you have an insecurity in that first initial piece, then the 1,000 pieces that follow it will all have that exact same insecurity. So something that we're doing within my team is how prolific or how frequent vulnerabilities or misconfigurations are within cloud environments, and then we'll generate a lot of noise and put the rabble out there and just be like, this is a bad thing, you guys should fix this, and try to get that known. So try to take a very complex issue, boil it down to the one or two individual parts that make it, and then how do we make that loud enough that people are like, oh, I need to fix this thing, and then the rest of it's going to be secure.
Sometimes I feel like people can be overwhelmed by the amount of different, the ingenuity of some of the attackers out there, the amount that's going on, and I suspect that sometimes people go, this is impossible to defend against. So I mean, looking at it from that point of view, what do you say to that? How do we start?
Right, exactly. Well, really good examples that we have recently, like say SolarWinds. Is a really good example. It's a supply chain attack. SolarWinds has a product, it's called Orion. And that product, the supply chain that builds that, or builds the infrastructure around that particular platform, attackers compromised the actual continuous integration, that CI pipeline aspect. And then they were able to implant inside of the infrastructure, not the code itself, not the actual SolarWinds product, but basically the infrastructure as a code template. They were able to build its own little template and then ship that off to clients and make it look like it's legitimate. So it's like attackers are actually, going as far left as they can, to implant a vulnerability so it gets implanted in the rest of the supply chain, and then the victims, download it thinking it's legitimate, and then now they're compromised. So it's an interesting attack. So it's something that we've spent a lot of time thinking about and noodling, like how do we actually, prevent that initial infection to begin with, and how do we stop that supply chain from being compromised?
Yeah, it's really interesting. I mean, there was I'm going to get the technologies wrong. I think it was NPM But there was an interesting one where a bad actor got in touch with the maintainer of a particular module and said, hey, can I just start maintaining this? And the maintainer at the time went, yeah, I don't use it, so sure. And of course, there were thousands of people, organizations depending on that. And by that really, you go, social engineering. It wasn't really social engineering. It was just saying, hey, can I have this? I mean, it's incredibly complex.
Sometimes that's all it takes.
So we obviously, apart from Apple TV and us doing our joint research on that, is there anything that's coming up or anything that's going on in the industry just now that you want to shout about just now?
I guess it's the reason I'm in this field. That's where I like cloud to begin with, is because there are so many areas to focus on and to look at. Talking about a supply chain attack is just one aspect of all of the various things you can do. I mean, it means I just mentioned Apple TV. It's like, what is that connection between IoT and cloud? Take Tesla, for example. Every single one of the Tesla cars running around the world right now has to communicate back with the server. That's the cloud infrastructure. So there's so many angles. If you want to look at IoT, if you want to look at cloud, if you want to look specifically at like how network meshes, work within cloud and how to dynamically scale networks. There's so many angles and aspects to it that are interesting and intriguing. For me personally, something that I find very interesting is within Unit 42, we're all threat intelligence, right? We want to know who's doing it and how they're doing it, whoever it is they are. And so there are specific actor groups that I want to look at and see them in cloud environments to say, this is how APT whatever is doing their actions. There's a lot of new research. There's a lot of really cool like cloud endpoint technology that's happening that allows us to really look at those specific actions happening on those individual instances that are happening. So more research is going to be coming. Cool things are happening, and just.
If I should get my notepad because I need to make notes here. But everybody watching will now be like that. Yeah, gosh, that Q guy's really, really turned on. I really like this guy. I want to be that guy. So, how does somebody become a threat researcher?
Yeah, great question. I think every threat researcher that I know and I've worked with and peers with and stuff like that has a very diverse background. We don't all start from the same spot. We don't all do the exact same things as we go. Threat research is all about thinking outside of the box, right? So what is the common core of what our industry does? And then if you want to be like an offensive threat researcher where you're actually like red teaming things and poking at things, you want to take that and say, well, there's vulnerabilities. How do I think like an attacker to break these things? Or if you're going to be like a threat intel threat researcher, you're like, well, how are people breaking these? So you almost have to think like an attacker, but then like, how do we actually detect these things and then put mitigations in place and things of that nature? So that background is very broad, right? It's very common to start within security operations centers, kind of where I started. I started within military as well. I was in uniform, so I started within threat intel to start with, which was great. But then you just broaden your horizons. Look at malware, look at threat analytics. Just how do you actually do analytics on threats, any kind of threat, any kind of analytics. Learn networks, learn how computers talk to each other, learn how cloud works. It's a very large list. But thinking outside the box, trying to find solutions to problems that are complex makes a really good threat researcher.
That is very awesome. So I think you've clarified that it really was with the military background. It has to be James Bond. I think is more that route that you're taking there, right? Thank you to Q for taking the time to chat with us today. And thank you for tuning in to this episode of DevSecTalks. Visit the link in the description below for more details on this series. And be sure to subscribe and turn on channel notifications to be the first to know about our upcoming episodes. And remember, if you're interested in being part of the DevSecTalks series, or if you have any topics you'd like to hear more of, let us know in the comments section below. I'll see you next time.